All right. In this lesson, we're going to take a look at some examples of similar triangles. And we've already looked at a few examples of these types of problems in class. We've looked at some examples where we have um, two triangles that are similar, meaning that they have the same shape. And really what it means is that their angles are all the same. But one is larger and one is smaller. So usually they have different sizes, but the same shape. And what we looked at with these kinds of examples is that we can sort of match up what we call the corresponding sides of the triangles. Now, sometimes it's a little bit hard to tell, like which one is the longest one and which one is the shortest one and which one's sort of the middle side. But those are kind of the things that we're trying to match up. Sometimes we can tell, like if we can see that the triangles look like they're kind of like set up going in the same direction. They're kind of rotated the same way. Then we're sort of looking for the sides that have the same position. So I would say that like the side on this big triangle that's 12 inches and the side that's 9 inches kind of go together. Those are corresponding sides. And also the one that is 8 inches over here on the left, and the one that we don't know that's marked with a question mark in the small triangle would also be corresponding sides. And then we also looked at how we could set up a proportion, and there's a number of ways that we could do this. But one way, for example, is we could say that, that 8 side sort of matches up with the unknown side, and 12 matches up with 9. And once we've set up that proportion, then we can go ahead and we can cross multiply and we can find the value of that missing side, right? So I'm not going to work through this one because we've done some like this before. You can finish this one on your own if you would like to. What I want to focus on in this video are a little bit more complicated problems like this one, where it looks kind of like we really just have like one triangle that has a line going through the middle of it. This is also a similar triangle problem. The key with this one is that we want to look at this actually as being two overlapping triangles. So there's sort of a little triangle here, kind of up at the top, that we can almost imagine it's really kind of a part of the bigger triangle, or you can almost imagine it as like a smaller triangle that has been like laid down on top of the big triangle. Right, so here's our big triangle. And so sometimes it helps to, if you're able to draw on the triangles, it can be helpful to, kind of highlight, like outline the triangles that we're talking about. So we have this little triangle. We'll outline that one in pink. And then we also have this large triangle. And we'll outline around the edge here as best we can. And those are our two similar triangles. Now, some people also find it helpful to redraw a problem like this and separate it out. Now, what I want to keep in mind is I'm still going to be doing kind of the same things. I want to be able to compare the sides of the triangles and find the missing measurement, the thing that we don't know. So I'm going to go ahead and redraw these. And I'm going to put, this doesn't have to be perfect, but I'm going to draw kind of a small triangle with like the same sort of general shape that we've got here. And the measurements that I know on the small triangle are 12 and then this 15 right here. So I'm going to put that down here. And then I also have this big triangle, which I did in blue. And I'm just going to kind of put this next to here. Again, not perfect, but kind of good enough. And this one now I'm going to think about a little bit, right? So for sure, I don't know this, bottom side. So kind of the way I'm looking at this triangle, the bottom side has a question mark there. I don't know what that measurement is. And when I look at the length on the original diagram, um, when I look at sort of that left side, they've taken that measurement and sort of broken it down into two parts, right? The 12 relates just to, like, that's the part of the, or the side of that little triangle, and it is partway down the length of the left side of the big triangle. So what I need to do is think about the full length of the side of that big triangle, which is going to be 12 plus 4, and that would be 16. Okay, so now I have two similar triangles. This is really a lot like the last example I just looked at, and I can set up two proportions, or sorry, a proportion, two fractions, and I can compare, 12 to 16 and 15 to the unknown side. There's other ways I could choose to set up that proportion. But that would allow me then to cross multiply. So I'm going to multiply 16 times 15 and then divide by 12. And when you do that, you should get 20 as your answer. And that would be the length of the unknown side. And I don't know what these measurements are, so we'll just put U for units. And that's how I would do that. So really the key is kind of looking at, like, where do we see two triangles that have the same shape? And how can we take the information that we have and sort of break down, like, what are the lengths of the sides of those triangles? So highlighting, breaking them apart into two separate pictures, both really good strategies. Let's look at one more example that is just slightly different from this one. So here we have another kind of similar setup, but this time the things that we know and the thing we don't know are a little bit different. So I'm going to think about this, or start off thinking about this the same way again. I'm going to imagine I have this small triangle. I'm going to outline this in pink right now. And I can see that the two of the sides of this small triangle are 6 and 9. And so I'll go over to the side here and actually just redraw this, kind of set up a little small triangle and recopy the 6 and the 9. Okay. Now I also have a bigger triangle, which again, we can kind of imagine is like sitting underneath that smaller triangle and then kind of sticking out a little bit more along the bottom. And if I were to redraw that one and think about the lengths of the sides of that triangle, I can see that that bottom side is 12. And sorry that triangle looks so crummy. That's don't judge that triangle. But that bottom side is going to be 12. And then the other thing I know something about is the left-hand side. But here's where it gets tricky, right? Is because this time I know that part of that side is 6, but I don't know the rest of that measurement. That's the thing I need to find. Now, if you look at other videos on YouTube and stuff, you're going to see a couple of different, a little bit more complicated ways of solving these kinds of problems. And those are great. They're not incorrect. There's nothing wrong with those other solutions. But I'm going to show you another way of thinking about this that will work. It's just going to require kind of an extra little half step. But that little half step is actually pretty easy. So here's what I'm going to do. They kind of marked this this little end here as X, right? That's the thing I'm looking for. But I know how to solve proportions when I know that I can match up corresponding sides of triangles, right? So it would be really nice if I just had a way to think about this left-hand side just kind of all by itself. So one way to do that is to add these two things together. But if I do that, I'm doing X plus 6. I think it starts to get a little bit complicated. That becomes more of an algebra problem. So what I can do actually is I can just say, like, just because they said that we're going to call this little piece here X, and we know that this other part is 6, I don't necessarily have to use that to solve the problem. What I'm going to do is I'm going to say, you know what, I'm going to think about all of this together. And for the purposes of solving or starting to solve this problem, I'm just going to think of this as my unknown, and I'm going to put a question mark there. I could put a variable or something there instead, but like now I've kind of turned that into a problem that I know how to solve. So from there, I'm going to set up my proportion. I'm going to say 6 over that unknown side is equal to 9 over 12. I'm going to cross multiply. And so we'll multiply 6 and 12 together and divide by 9. And 6 times 12 is 72, and 72 divided by 9 is equal to 8. Okay, so this is really the same kind of calculation, same process that we've used to solve other problems. Now, here's where the last little step comes in. What I have to remember is that 8 is not really the thing that they were asking for. 8 is the total length of this left-hand side over here that includes the 6 and this little unknown piece. So now I just have to do kind of a simple little subtraction step in my head. If this entire thing is 8, and I already know that this piece up at the top here is 6, that means that x has got to be equal to 2, right? That's not advanced math to figure that out. I can work my way to getting that solution. Okay, so kind of the takeaway from this is that there are lots of different strategies for solving problems like this. Sometimes we can make a problem simpler by looking at it in a different way, or relabeling it, or thinking about how we talk about it. And when we can do that, let's find a way to do that and make it simpler for ourselves. All right, now that you're done watching the video, go ahead and take a look at the practice problems that follow. Thanks.